All right, kids. We are, you notice, on 5.5, and there is no 5.4. So the reason for that is because I'm making the executive decision to, at least the year of recording these particular lesson videos, we're going to skip 5.4 and we're going to kind of move that content to pre-cal. We're doing that. The reason why we're doing that is because I teach basically a non-graphing calculator Algebra 2 course, and I stand by doing that. I think I still feel like that's a really good idea. I felt that I've seen lots of good evidence that it's a solid plan, so we're going to keep doing that. And I really think 5-4 really is a better lesson for if you have a graphing calculator and you do stuff with that, because I think there's a lot that lends itself there. So we're going to skip that lesson. We're going to do solving polynomial equations. We're actually going to barely look at any, if at all, look at any examples of solving equations. We're really going to look at like factoring on steroids. It may be a better name for this particular lesson. So let's dive in. We're going to learn a lot of stuff. A lot of it's not necessarily hard. There's a couple of things that are pretty tricky. The last thing we're going to learn is pretty tricky, but it's really helpful for for the future. So the first thing we're going to learn is we're going to have to learn how to factor a couple of special cases that you see all over the place. So if we have a sum of two cubes, so a cubed plus b cubed, or a and b can be different things, right? All right, and all that stuff. But you always factor it with this formula. You factor it into a plus b times a squared minus ab plus b squared. All right, you notice for the sum of cubes, this one on the outside is plus, and then there's a minus in the middle. So plus and minus on this one. You notice the difference of two cubes is the opposite. When we have the difference of two cubes, we have minus here, and then it's all pluses on the inside. So minus plus. So sum of cubes is plus minus. The difference of two cubes is minus plus, right? And other than that, the formulas are the exact same. These are things that you're going to have to memorize. Let's look at some examples of factoring those things. So we have right here maybe a sum of two cubes. Well, let's take a look. We've got kind of a mess here, right? So what do we always look for first when we are factoring two things, or any number of terms? We look for a GCF, right? So is there anything that goes into both of those? Well, both of these are definitely divisible by 2, the 16 and the 54. So we can pull a 2 out, right? They also both have an x in them. So let's pull an x out. So we pull a 2 out. Excuse me. 16 divided by 2 is 8. This could be 8. And then x to the fourth divided by x is x cubed. 54 divided by 2 is 27. So this turns into plus 27. And then x divided by x is just 1. And so all we're left with is y cubed. Well, okay, so now we do have a sum of two cubes, because 8 is 2 cubed and 27 is 3 cubed, and x cubed is x cubed, and y cubed is y cubed, right? And so we have a sum of two cubes. We can use that formula. So it's probably going to be helpful to write down what A is and what B is. That way it's going to be easier when we start plugging it in here in a minute. So in this case, so if we go back to our formula, let me bring that back up. A is this without the cubed bit, right? So you could say that A is the cube root of this whole thing, right? Which is, for the variables, that's easy. You just take the cube off, and then you have the letter, right? But for a number, which we're going to see in this example, you take the cube root of it to figure out the A. So the cube root of 8 is 2. 2 times 2 times 2 is 8, right? And then this one, we just take the cube off and turn that into x. So B in this problem would be 9, because the cube root of 27 is 9, and then y. All right. So now that we've kind of got these set aside, you don't necessarily have to do this, write them down. It just can be really helpful to know what we're doing in a minute, because we're just going to plug it into that formula. So the 2x is going to just hang out on the outside. So the first part of the formula is just a plus b. So 2x plus 9y. And then it is a squared. Excuse me. So I'll put 2x and then squared. We'll do it in a couple steps. And then minus, plus minus, ab, right? So 2x times 9y plus b squared. So 9y squared. We got to clean up anything that we can clean up. This stuff out here is just going to hang out. So 2x times 2x plus 9y. And then this, we've got to basically distribute, right? So 2 squared is 4, x squared is x squared. And then minus 2 times 9 is 18, and then xy. And then plus 9 squared is 81. And then y squared is y squared. Now, this problem is now finished. It's important to note, and we're going to see some stuff kind of like this, that you might not be finished on this step, and you need to double check, because it can happen. It does happen sometimes to where either this one or this one will factor some more, right? So you might be able to do trinomial factoring in this example over here, or you might have a difference of 2 squares. You wouldn't have a difference of 2 squares if it was sum of cubes, right? But if it was difference of cubes, you might end up with a difference of squares. So there might be places where you can factor some more, or you may have a GCF in here if you didn't actually GCF right before. So it's possible that you may be able to factor your end result more than this. For this problem, it can't factor anymore. That's totally done. So now this, we're about to blow this off the rails, right? So I wanted to kind of remind you factoring by grouping, right? Factoring by grouping is a problem kind of like this. Usually we're going to have some squareds and some things and whatever else in there. But factoring by grouping, we've learned previously in something with 4, and I'm now adding that it can be for something with 4 or more terms, right? And that's where you take and you split it into 2 things that have a GCF in those things. So if I was to factor this kind of example, reminding us how to do it, if we look at these first 2, we can pull an x out of that. We pull an x out, there's an a plus b left, right? And then on the second one, we can pull a y out, plus y. And then there's an a plus b left. So when we factor by grouping, what we want just exactly what we have here. And this is hopefully review. If not, we're diving in the deep end. Strap in and we got this, right? But what you want when you factor by grouping is you want 2 kind of monster ugly terms that have something in common. Just like we have here. Because these are kind of monster ugly terms. Remember, a term is a product, right? So we've got this times that, so it's a product, right? And these have things they have common things. They both have a plus b in common. So we're going to factor out an a plus b, right? So we pull an a plus b out to the front. And then we pull an a plus b out of this one, we're left with x. When we pull an a plus b out of that one, we're left with a y. So that's how this kind of example would factor. So that's factoring by grouping. We've hopefully done that before. So let's kind of jump even further and do a more Algebra 2 example. Oh no, we've got trinomials. We've got all kinds of things. So we're still basically going to do this the same kind of way. In this particular problem, we're going to split it right down the middle, right? We're going to split it right down the middle. We're going to look at this first chunk and this last chunk. Now, I noticed that I probably wrote something down wrong. Minus 4x squared minus, this should be, I didn't write something down. I didn't write something down wrong. I just made it look like that plus was a minus. I didn't write something down wrong. I just confused myself. It's getting late, like actually late, not just like 8 o'clock. It's getting late. So anyway, what's in common in these first few terms? Now, what you're going, I think I did write something down wrong. Plus, minus, minus, positive, positive, minus. Oh, okay. So I didn't write anything down wrong. X cubed minus 7x minus 4x squared plus 10. Aired minus 28 minus 40. Something should be minus or something that's not a minus or something. Pause. I didn't write anything down wrong, but I did say something wrong. So I said we're just going to split this in the middle. But a flashing clue actually in this particular problem that this is not the order that we want this in. And in our last kind of example, we didn't do this, but previously, probably when you've done factoring by grouping, sometimes you have to rearrange it to where the first half and the last half are going to match. Now, so if the signs don't line up or aren't completely opposite, like this one, see, we've got positive, positive, negative, and this one we've got positive, negative, negative. So they're not completely backwards, right? So like if I was changing this to negative, this would be this, then they wouldn't match, right? And so they don't match or opposite. So this is not going to work. So I know for sure I need to rearrange this. Now, the only way to know whether this works is to like do a step or two, but I can already have a clue that this isn't going to work, and I can be like, okay, I'm going to need to rearrange some things with the commutative property. So I'm going to take and I'm going to move these two squared terms. Okay. I want two sets of things, the front half and the back half. I know I want them both in descending order. That way things are going to match that way. So I want them both in descending order. That's one thing I need to know, right? There's a lot of stuff in this particular lesson that's kind of trial and error, and it's going to take a lot of practice to get us there. It's kind of like, I've talked about this with other things before, and this is definitely one of them, where this is kind of like balancing chemical equations in chemistry, where this is going to take practice to be able to see into things, right? And sometimes you got to try it. Use pencil, not pen. Okay? So move that negative 4x squared minus, 28x minus 40. So once I have something where the signs either match or, like in this case, are completely opposite. So I've got positive, 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 and now back here I've got negative, 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 right? So they're opposite. One side I've got one type of thing, and the other side I've got another type of thing, right? So either they all match signs or they're opposite. Once I have that, then I'm going to take and split it up, right? I'm going to split it up just like before. I'm going to take the GCF of the first half and the GCF of the second half and see what happens. So in the first half, in common between these three things is an x squared. So I'm going to pull an x squared term out. X to the fourth divided by x squared is x squared. 7x cubed divided by x squared is 7x. 10x squared divided by x squared is 10. Now this one, I know that I want my signs to match. And so on this one, I'm going to pull out a negative 4 because 4 goes into everything. If there isn't a number that goes into them, you can still flip the sign by just pulling out a negative, right? Just a negative 1, right? And there's no x's that go into these, so just a negative 4, right? So I've got an x squared left on the first term. I've got a minus 7x, plus, got to flip the signs, plus 7x and plus 1. Doesn't match because this should be a 40. Yeah, 40. It was a 40. I told you it was late. It's like really late for me, but here we are. We're doing it. So we've got a term over here and a term over here, and look, they match. So let's factor out an x squared plus 7x plus 10, and then write what's left. So what's left from the first one is x squared, and what's left in the second one is minus 4. Right? Now, we can actually factor this further this time. Remember, that's a thing that can happen sometimes. So this one is a trinomial, easy peasy. Two sets of parentheses, open, close. First slot, x and x. What's two things that multiply to get 10? So it could be 10 and 1, 5 and 2. Let's do 5 and 2. Can we add or subtract those to get 7? Yes, we can. Plus and plus. Now, on the second one, we can also factor it some more because we got a difference of two perfect squares. How do you factor the difference of two perfect squares? We do two sets of parentheses. Square root of the first one. Square root of the second one. Plus and minus. Then we can actually go one step further because we got two that match, so we can even write that with multiplicity and write x plus 5 times x plus 2 squared times x minus 2. If you just circled this one, I probably wouldn't count off, but I think that's even a cleaner answer. All right, let's do another one of those because those are tricky. All right, so first of all, looking at this, we're going to factor this. Factor. Might even say factor by grouping. We're going to factor it, right? So we've got positive, negative, positive, negative, negative, negative. So this is definitely not cool, right? So what could we rearrange? How could we make this work? Negative plus negative, negative, negative. Okay, great. So this has got to go in one and this has got to go in the other, right? Because they're the only positives on there, right? So 2x to the fourth minus 3x squared. I can't keep this. No, not squared, cubed. I can't keep this x squared term, so let me move this one over there. The minus 5x squared. Let's move that one with that set. Who knows? So let's move this one over here. So now we've got a plus 12x squared minus 18x minus 30. All right? So now I've got positive, negative, negative, positive, negative, negative. That looks great. I've got descending order on both of them. That looks good. Let's try it. Let's split it in half and see what happens. So we've got an x squared in common on the front. So 2x squared minus 3x minus 5 is what's left. I've got, let's see, looks like a 6 in common on this side. That was in common. Yep, look at that. So plus 6, and then what's left is 2x squared minus 3x minus, what are we taking out? A 6, so 5. Look at that, it matches. So we're going to pull out a 2x squared minus 3x minus 5. And then what's left is x squared plus 6. Right? Can we factor anything else? Well, we can't factor this guy. It's not a difference of two squares. It's a sum, but it's not a sum of cubes. So we can't factor it anymore. So he's as factored as he can be. Now this one, let's give it a shot. See what happens. So 2x and x, right? Two things that multiply to get the first term. Two things that multiply to get the next term. So 5 and 1. See if that works. 5 times 1 is 5. 2 times 1 is 2. Can we add or subtract those to get a negative 3? Yes, we can. Put the negative right there. Follow the nose. Put minus and plus. Do the signs work at the end? Negative times a positive is a negative. He works. This is completely factored, and it's as simple as it can get because this one doesn't factor anymore. And there's nothing that's repeated. Looking great. We're getting closer by the second. All right. Now, oh, look. We got a complicated thing here that looks simple. That's like deceptively scary. That's deceptively scary, right? So here we've got a difference of two squares. Wait, what? Okay, so we have a difference of two squares. We're going to talk more about what I'm about to show you in a second. This is going to be kind of a precursor for the like real mind-melty stuff that we're going to see here in a second. So I can write this as x cubed squared, right? Because if I have power to a power, I can multiply the exponents. So x to the sixth we can rewrite as x cubed squared. Okay, if we can do that, we can do this same thing over here and change it to y cubed squared. So now we have a difference of two perfect squares. So let's factor that into square root of the first. So x cubed, square root of all that is x cubed. Yeah, sorry. Did I mention it's late? Square root of the second, y cubed plus and minus. Look, now I've got a sum of cubes and a difference of cubes. So we can factor that some more. So this first one, we can factor it into x plus y, a plus b, right, times a squared. So x squared minus a times b. So x times y plus y squared, so it's like b squared, right? Same idea. Same thing here, but with all the different signs. So x minus y times x squared plus xy plus y squared. Wow. That's crazy. Cool, fun noodle, something. That's great. All right, so hopefully you're still with me, because I think this last thing is the most mind-melty thing from this lesson. I really like having this in here in Algebra 2. This is the earlier you get exposed to this and the more practice you can get over time, the easier it's going to be in pre-cal and in calculus and all these other courses where you have to do this kind of thing. And so the first thing, this is not the mind-melty bit, it's the example. But the first thing that you need to know is, what is quadratic form? So quadratic form is this, where we have a u squared plus bu plus c. U can be whatever, like it can be anything, right? We can put anything in for u, right? I'll show you in a minute. So u doesn't have to be u. U can be whatever. U is just a placeholder variable, right? But this is quadratic form, where we have a coefficient here, and we've got x squared or u squared, u term, and then an OU term. So that's where our goal. So let's do the example, and then we're going to be through. So here it is. We're going to write this in quadratic form if possible. So our goal is to have this have a u squared and this have a u. We don't really care about that one, right? So let's start by looking at the variables. So what we need for this to be this squared. That's kind of our goal here. So let's start. I'm going to kind of in the margin over here, I'm going to start building u. U is going to have n to the fourth in it. So can I write n to the eighth as n to the fourth squared? Yes, I can. That's the if possible part. If the answer was no, then this would be impossible. I wouldn't be able to write this as that. So I can turn this as n to the fourth squared. Right? That's good. Now, that's not so hard. That's not so bad at all. The tricky part is where we look at can we get the number simpler? So we need to be able to write something with this. Well, no, be better say it like this. Something with this squared. No, it's going to be easier just to show you. Let's start by writing some of the factors of 40, right? Like we were going to factor this thing. All right, so what are the factors of 40? Well, 1 and 40, that one's useless in this context, but we'll write it down anyway. 2 times 10 and 2 times 20, 4 times 10, and 5 times 8, right? Those are the factors of 40. We can switch the order, but we're not even worried about the order right now. Okay, so getting those down. Now, let's kind of think about some factors of 150, right? So 15 and 10 comes to mind. And 25 times 6 comes to mind. Now, I'm going to stop right there, okay? Because what we need to start being able to see, and the way we figure out what to do, is we need to find something from this list that if we square it, it will give us something over here, which we have discovered. Because 5 squared equals 25. So something squared over here equaling something over there. Okay. So this is how we're gonna write this. Okay. So plus 8 times 5. So we're saying that u is going to be 5 into the 4th. Okay, so let me erase this. So if I put a 5 here, 5 squared is 25. 5 squared is 25. So what I'm going to multiply on the outside is 6. Minus 15. So now we're in the form 6a u squared, u being 5 into the 4th, plus b, 8u, again, u is 5 into the 4th, plus c, minus 15, right? That's it for this lesson. Hitting just shy of 30 minutes. Think we did okay for a jam-packed lesson. I shall see you in class. If you're not one of my students, hopefully this is useful to you. Let us know how you're doing and how else we can help you in the comments below. Have a great day. Bye-bye.